Okay, back to my setup, to my desk, my PC, my mic. This is chemistry topic 1, experimental techniques, questions 1 to 17. It's nothing too hard. But before starting, I want to thank you guys. Yes, or 2 days ago was the 1 year anniversary of this channel. Thank you so much for the support over the past year. It's really been it feels like last week صراحة. I uploaded term 2, I think it was week 2 math CA. But anyways, thank you so much for the support. I know we all benefited, myself as well as all of you guys. ونحن انه we built a community, it's not just a channel. Thank you so much, and inshallah it's gonna be another year ahead of us. Anyway, separation techniques, define an element, a compound, and a mixture. I'm gonna skip this. You can pause and read if you want. Of course, an element is a substance, you cannot be split, right? A compound is a substance made of 2 or more elements, right? But what's the key word? Chemically combined together. That's a question that came. A mixture, all of these three were, this was one question, second question, third question in the CA. They were 3 separate questions. And then a mixture is something that is not chemically combined. Okay, this is the key word here. Okay, classify as element, compound, or mixture. أكيد blood is a mixture because there are stuff that isn't dissolved in blood like clots and whatever. Oxygen, of course, it's an element. Ammonia is a compound, NH3. Orange juice, you guys know the pulp in orange juice. Some people will call it a solution. It's a mixture. The pulp, I think you guys know about it. The small pieces in the orange juice. Briefly describe how to separate salt and sand into its constituents. Of course, salt and sand, right? So the first thing I'm thinking is use water, right? Place the mixture in a beaker with water, right? When you put it in water, uh, obviously the sand isn't going to dissolve, but the salt will, right? They're saying heat it until it boils or still hot. Okay, so I saw the word decant the mixture. If I pause the recording to check, I was a bit confused, but many people skip this step. But basically, if you see, there's a process called decantation. It's basically when you have this is a beaker, okay? You have a liquid down here, let's call it, I don't know, some black liquid, and you have a liquid that's floating on top of it over here, okay? Decantation is when you separate 2 immiscible liquids from each other. Okay, so that's it. You'd say طب okay شو خص sand بالموضوع. Basically انت when you have a mixture of sand and water, okay, the sand is gonna sink down here, right? There's gonna be sand over here, but there's still gonna be sand pieces over here. فانت when you do decantation, it's basically separating the liquid part from the other part. فانت when you pour it now in a new glass, you pour it here, there's still inside the liquid, there's still gonna be these yellow sand pieces. Okay, some people they skip this step, they go directly to filtration. But the problem is there's too much sand to do filtration. So they do this step here, that way there's little sand left, and now you can actually do filtration. So you get this mixture, filter it in a separate beaker. The sand is obviously going to be the residue, and transfer the filtrate. You have the sand separated, right? But don't forget, we still have salt in our liquid. We're trying to separate the salt from the sand. So now until you have salt water mixture, right, you do crystallization, right? Transfer on evaporating dish, you heat it, and you get crystals. Question 4, what process can be used to separate dyes? Of course, chromatography. Give the name of an apparatus or the name of technique you can use to separate a mixture of sulfur and steel. Sulfur and steel, okay, yeah. It's not necessarily water and dissolving and whatever. It was in the notes, and basically what the region said in the notes is when you want to separate 2 things, think of something, think of a property one material has that the other material doesn't. And in this case, obviously, it's magnetic attractiveness. Steel is attracted to a magnet, however sulfur isn't, because they're both powders, and if you want to look at dissolving in water, I don't think either of them dissolve in water. So you can use a magnet to separate them. If you get a magnet, all the steel is going to be attracted. Cooking oil and water, obviously you can use decantation. Yeah, we used to call it, we didn't used to call it decantation. I remember, and it came one time in our periodic in grade 10, and many people got this question wrong. They asked us to draw how you would separate oil and water. And you basically had to draw a funnel like this. Yeah, and you basically had to put water here. Obviously oil is gonna float, yeah? You put water up and you would you'd say this is water, and you'd say this is oil. This is what decantation is, and then the water goes down. Obviously you have to draw a beaker down. In case they ask you to draw, maybe they do, and I'm not gonna make any promises because at the end of the day I don't know. But I feel no, you should be prepared to know how to draw in case it comes. I don't know, I have a small feeling that you're gonna be asked to draw something. Okay, question 6, name the most suitable technique used to obtain crystals from its aqueous solution. Okay, very easy. What's the process to get crystals? Acute crystallization. It's a good question. How do you do crystallization? It's steps, right? The first step is you heat it on a Bunsen burner, right? Heat on a Bunsen burner until most of the solvent evaporates. Keyword is most, okay? Why is this? Oh shit. Keyword here is most, okay? Why is it this kind of thin? No, it's not. Okay, I don't know why it looks very small for me. Anyway, so until most evaporate. Why is it? Until most of the solvent evaporates. That's the keyword in the first step. Okay, so heat until most of the solvent evaporates. After most evaporates, you transfer it to a water bath. Okay, you transfer it onto a water bath until the remaining solvent evaporates completely. If you want keywords to help you in the multiple choice, of course, if it comes written, that's a different story. In the multiple choice, how I memorized it, okay? أول شيء Bunsen burner is the first step. Okay, heat on Bunsen burner until most evaporates. This is always the first step. Okay. After that, there's the second stage of transferring. Transfer the mixture to an evaporating dish. That's always the second step. Okay. Then after that, carefully. You see, heat carefully. That's always the last step. Okay, because you don't want to burn the dish. Okay, so heat carefully. That's how I memorize. These are the keywords. And then obviously until remaining solvent evaporates completely. Okay, this is obviously the last step. These are just keywords I memorized. Question 7. Which of the following mixtures are separated by simple distillation? Simple distillation is used to separate solutions, okay? Fractional distillation is used to separate two liquids with close boiling points, okay? So simple distillation, sodium bromide aqueous solution. Obviously, yes, it's a solution, right? We can separate the bromine from it. Sand, salt, and water mixture. The sand isn't dissolved in the water, so obviously that's gonna be wrong. Water alcohol solution. People will say, oh, it's a solution. But why is it wrong? Because they both have close boiling points. For water alcohol, it should be fractional distillation. Sugar and water, obviously it's correct because it's dissolved in it. Any mixture of miscible liquids having close boiling points, obviously no. That's fractional distillation. So it's just gonna be A and D. Let's take a look. Yeah. Which of the following are separated by fractional distillation? Ethanol, water. For those who don't know in grade 11 what ethanol is, it's alcohol, and alcohol and water have close boiling points, so it's correct. Oil, water, it's not even dissolved in each other. Salt water, no, use simple. Sugar, alcohol, simple. Any mixture of miscible liquids having close boiling points, like we did in the previous question, of course it's correct. So A and E, yes. Okay, the following shows the chromatogram of a dye that was separated into two components A and B using paper chromatography. Which of the following components of the dye is more soluble in solvent X? Obviously, the one that's more soluble in solvent X is A, because it's further and has the least affinity. If they just ask which one has the least affinity, affinity is the ability to, let's say, stick, okay? Those who are doing AS Bio, I'm not doing it anymore, I dropped, but you've come across this word affinity. I think if you're doing AS Bio, you don't watch my videos, you're too smart for my videos. But affinity basically is the desire or the ability of something to stay close to something else. Okay, we did it in the action of enzymes. So if you have this enzyme over here, okay, and you have I don't know, this substrate that it acts upon, if this enzyme has high affinity, man, it's gonna stick to this substrate more easily. Okay, so here's the thing: when they say affinity, you think the opposite. You don't want it to be sticking. Why does A have the least affinity? Because it sticked the least to solvent X. B stayed closer to solvent X, but it's sticking to solvent X, okay? I hope that kind of cleared up. Obviously, this is in case they ask it, in case our regional decides to switch up on us and just asks which one has the least affinity, which one has the highest affinity. Okay, so least affinity is the one further away. Okay, find the RF for component A. RF, it's so easy to find RF. You find the distance traveled by it and divide it by the total distance of the paper, and you're gonna get 8 over 12, which is 0.67, I think, to two significant figures. Yeah, 0.67. A mixture of amino acids is a colorless solution and can be separated during chromatography. Describe how the chromatography procedure should be adapted to reveal the amino acid spot on the chromatogram. Obviously, you need to use radiation, right? UV radiation. I don't know, I always get mixed up with this, and I did now. I was gonna say infrared, and I remembered infrared has zero, like its penetrating power. We did it in physics, it's very weak. Okay, so that's why UV radiation, you want something strong from the sun. Like, مثلا, a good example is when you're in the sun, your head starts to hurt, right? When you're in the sun too much, like the sun's hitting your head hurts. Okay, you can think, the amino acids, it's like the proteins in your head, they start to break down, so your head hurts. So the chromatography paper may be exposed to UV radiation to reveal the spots, or it could be sprayed with a locating agent. So either you use radiation to locate it, or you use any other locating agent that forms different colors. This is, you memorize this, huh? Question 11. You're given a sample of a colorless liquid and told that this is water. How can you assess the purity of the given sample? I'm just going to show you the answer, okay? To show something is pure, okay, a pure sample, معناتها it should have, يعني مثلا pure water is what? 0 degrees Celsius freezing and 100 degrees Celsius boiling, right? So you want to see the purity of it, check how close it is to the boiling point, freezing point. I guarantee you the water you have in your house, it does not freeze at exactly 0 degrees Celsius. The water, مثلا get water from your tap in the bathroom, put it in a cup, and if you have a perfectly controlled freezer at 0 degrees Celsius and you put it in, it will not freeze at 0 degrees Celsius. It maybe you'll see small crystals developing, but it will not. It will take way longer to freeze. This is due to the fact that the water in our houses are not pure, especially the ones we drink. There are many minerals dissolved in it. Okay. Working with gases 1.4, calculate the molecular mass of H2S and NH3. Compare their densities under identical conditions. Okay, so few people, I read this now, I got a bit confused. But obviously, calculate the molecular mass of H2S and NH3. Any baby can do this that has done simple chemistry. H2S, you have hydrogen is 1 and sulfur is 32. So 2 plus 32 should be 34. Okay, get a periodic table and do it. I'm not going to explain. NH3, 14, N is 14, H is 1, you have 3 H's, so 14 plus 3 is 17. Compare their densities under identical conditions. To compare densities, you can, because density is equal to mass over volume. Okay, under identical conditions, you guys know gases, they depend on the condition. So if they have the same condition, the volumes should be the same. So you can just cancel the volume. So then the densities will just be equal to the mass. Since the density of H2S in this case would be 34. Okay, if you ever want to like compare densities under identical conditions, obviously don't write any of this. Okay, just say as density of H2S would be 34, NH3 was 17. Compare their densities as a fraction. When they say as a fraction, whenever you have two numbers you want to compare them, divide by each other. 34 divided by 17 is equal to 2. Thus, H2S is double the density of NH3. Okay, let me open the answer for you. It's 2 over 1. Okay, say 2 over 1 because they said as a fraction. Okay, I got 2. Then they said, which of the above two gases collected by upward and downward delivery? This is the first time I see this. I think we skipped it in our class. But working with gases, again, obviously, if you're studying for a periodic and you only do CQDs, عفوا إلك, بس I think you're lost in your life. Don't do CQDs only. But you always have to do notes, okay? Read over them. Even in the CQDs, there's stuff that isn't mentioned in the notes. Okay, even in the notes, there's stuff that isn't mentioned in the CQDs. Okay, so if you're just doing this, there's a lot of stuff that's in the notes. So working with gases, you have 4 cases. Okay, 4 methods. Okay, if you use a gas syringe, the density doesn't matter, right? Of the gas. خلاص, this is just gonna go up into the syringe, right? You're gonna capture it. But if you're using upward delivery and downward delivery, أكيد there's gonna be some problem, and it makes sense. If something is less dense, if the gas you're collecting is less dense, then obviously it's gonna float. It's gonna go up. So if it's gonna go up, if the gas is less dense, it's gonna float up. So انت برأيك, in your opinion, if the gas is gonna float up, am I gonna use for upward delivery or downward delivery? Of course I'm gonna use upward delivery, right? Because the gas is going up, it's less dense than air, right? However, if the gas is denser than air, if it's denser than air, then you're gonna use what, downward delivery, right? طيب. If it's collected over water, okay, for a gas to be collected over water, it must be insoluble in water. What? Gas of low solubility. Oh, okay. So the fourth method is being collected over water like they did here. Okay, it just has to have a low solubility. It just can't be soluble in water. So you can do this for any other case, as long as the gas is insoluble in water. And you have three cases. I'm gonna go over one of these one by one. Okay, for the gas syringe, it's nice and cute. We do it all the time because it works with any gas. Okay, for any experiment, this is the easiest one. Then, if something is less dense than air, it's gonna float. The most common ones are hydrogen and ammonia. Do you memorize these? In my opinion, just look over them if you see them, you know what I mean? Chlorine, for denser than air, you have the heavy gases like chlorine, sulfur dioxide, hydrogen sulfide, nitrogen dioxide, carbon dioxide, HCl. Then for the ones of low solubility, the ones that work with water are these. Okay, oxygen, hydrogen, nitrogen. Okay, like oxygen doesn't dissolve in water, hydrogen doesn't dissolve in water, nitrogen doesn't dissolve in water. Okay, now the way they did it in the course division isn't memorizing way. They gave you the number in the solution. Look, so they said the density of H2S, hydrogen sulfide, is higher than air. They gave me the number of air, 29. Okay, you can just say 29. So if you want in the exam, if you ever get this question, and we haven't been asked it yet in any of our CAs, but if you get something to do with denser than air, downward delivery, upward delivery, check compared to 29. H2S is higher, it's 34, it's greater than 29, so it's denser, so obviously it's going to go down, it's going to sink, so downward delivery. NH3 we said is 17, so 17 is less than 29, so it's less dense than air, so it's going to float, right? So it's going to go upward delivery. Perfect. So you can continue reading, but anyway, drying stuff, you can read them. Name 2 common drying agents that are used to dry gases. Oh, perfect. There are 2 here. There's a solid one in the notes, solid drying agent and liquid drying agent. Okay, these are just stuff you memorize. Basically, they're used to dry either a solid or liquid to take the water out of it. Here, it's anhydrous calcium chloride because it's gonna absorb the water, obviously, for the solid. And for liquid, it's concentrated sulfuric acid. Okay, you just memorize these. You see them, memorize them. So anhydrous calcium chloride and concentrated sulfuric acid. Type. 14, name 3 gases that are highly soluble in water. Let's see. Ammonia. These ones, honestly, I didn't know them. And these are stuff you have to memorize. Ammonia obviously is soluble in water. This was a question we had before. Sulfur dioxide, hydrogen chloride. You memorize these, you know. Can they mix with water? The easiest ones, the easiest gases that I can think of are the acids and bases. Okay, acids and bases will dissolve in water, right? Why? Obviously, they dissolve in water. When you mix HCl with water, you get bleach. I think you guys know it. Sulfur dioxide when you mix it with water. You remember the titration when we used to do titration? The titration, yeah. Acids and bases, they're soluble in water. Obviously, in the case that they don't remember. But wait, no, don't memorize that. Just memorize these 3, okay? Memorize them. Because not all acids and bases are soluble in water. I just remembered. Okay, خلاص, just memorize these three nice gases that are soluble in water: ammonia, sulfur dioxide, and HCl. Draw a label diagram of a setup. See, this is why I told you should know drawing. Draw a label diagram of setup you can use to make an aqueous solution of a highly soluble gas in water. So they actually gave you 2 here in the diagram. They have inverted funnel and the syringe here, or the test tube, or whatever you want to call this. This is, it's very easy. Obviously, if it's soluble in water, then it should be heavier than air. Wait, no, don't, because ammonia is less than water. Forget about that. Anyway, So to put a setup to create an aqueous solution of a gas and water, obviously either NH3, SO2, HCl, تاخد a tube. Of course, this tube should be filled with water, right? Okay, and you want to put a pipe down through which the gas will travel, right? And of course, it should go out. The pipe should go out. You close this pipe as you close the lid. I'll make room for another pipe to exit. The first pipe should obviously be submerged in water for the gas to enter the water. The other pipe can just be like this, هيك طلع. Okay, and this is exactly what this is. Okay, very easy. Label it. Obviously, you're gonna label this as the water, and you can label this as the gas in. You could say like gas in. You have this one being the inverted funnel. That also works, of course. You're just gonna have to pump the gas through the funnel. Again, if you want to use inverted funnel, you should label it. Okay, you should write inverted funnel. And label the water down. And please keep the funnel submerged in the water. It should be inside the water. Okay, top questions. Question 15. The table below provides the RF values for 4 amino acids: lysine, glycine, proline, and valine. The following diagram shows a chromatogram for a mixture of 2 amino acids, R and T. Okay, so في R وفي T. What are the identities of amino acids separated? Okay, so they gave us the RF values, and remember that the RF value is equal to the solvent front. شو قصدي, sorry, it's a distance traveled, my bad, it's a distance traveled, right? Distance traveled by it over the solvent front. Here's a common mistake people say, and what I did earlier was divided by the length of the paper. The thing is, when you have two distances like this, 13 and 14, you're gonna ask yourself, which one do I take? Many people are gonna take 14 because they're gonna say, خلاص, that's the length of the paper. People are gonna say, what? Okay, what's the solvent front? Okay, here's the thing. انت I'm gonna give you an example. Okay, so this is a good example over here. This one here. Okay, so the solvent front, I think you can see the paper here is white, and then the paper here, it's kind of like the water. When water gets on paper, it's like grayish color. Okay, so the furthest distance that this gray thing traveled, that's called the solvent front. So if I were to find the R value for these ink dyes, I wouldn't divide the distance of the ink, the distance traveled by the ink, by the whole paper. La, I'm not gonna do this. I'm gonna divide the distance traveled by the ink. I'm going to divide it by this distance over here, because this is the furthest distance that the solvent traveled. So I'm going to divide by this distance. That's what I divide by. In the other question we did in the course revision, where they told us to calculate the RF value, that was, they gave us like that was the solvent front. It was just one distance, so you didn't really have much to choose from. But here, when they give you two and they give a solvent front, you divide by the solvent front. Okay, just so you know. And if you get it written for some reason, please don't say divided by this by length of the paper. You're gonna get 0. Anyway, we know that the solvent front is obviously 13 in this case. So in this case, the RF would be something over 13, right? So we have a few options here, which one's which. We can easily find out R and T, right? We have R and T. Let's see, R and T. R is 8.2 centimeters, right? So let's find what's the RF value for R. I'm gonna erase this. The RF of R is gonna be 8.2 divided by 13, and we have to match it to one of these. So let's see, 8.2 divided by 13, you're gonna get 0.63. Okay, 0.63. This is RF of R. How about RF of T, right? It's gonna be 6.16 divided by 13. 0. We can just say 0.47. Okay, so I'm checking the answer here, and they got 0.6, 0.43. I'm seeing they did -1 up and down. I'm like, why? It took me a few seconds to see this 1 centimeter they gave here from the baseline. I didn't read the baseline. Of course, that's something you should pay attention to. Pay attention to when solving. If I do obviously 8.2 minus 1, you should have subtracted by 1 for all of these, right? Because the distances you should take is always from the baseline, and the baseline is 1 centimeter above the original point, so you should obviously subtract by 1. And when you subtract by 1, you should get the same values in the table. Let's see. If this was multiple choice, it wouldn't matter because 0.63, it's close to valine, right? Divided by, just say 12, 0.6, so it should be 0.6. And the other one, I'm just gonna divide it by 12, 0.43. So obviously they're close to the ones in the tables. If it was written, it would be wrong, okay? Obviously, so R would be valine and T would be proline. Yeah, okay. So the answer would be R we said was valine, T would be proline, so D would be the answer. The apparatus shown is used to collect gases. Name the apparatus A, B, and C. Obviously, I think A is, let's see, maybe syringe, I don't know. Okay, so it's a tap / separating / dropping funnel. So it's a funnel. Okay, it's a funnel dropping a gas in. But obviously it's not a burette because burette cannot deliver gases, guys. So this could just be a delivering funnel. That would be an easy one. Or no, not delivery, just say dropping funnel. Yeah, that would be correct, right? Focus on the tops for your written, guys. So this is a dropping funnel, okay? Tap funnel, okay. B would be said delivery tube. Yeah, delivery tube. Of course, I can guess that makes sense. So the gas, I figure should come, or no, it's a reaction happening. Reaction mixture. You're dropping maybe some of the reactants in, and when you drop these, they're gonna react and form a gas. That gas flows through the delivery tube into over here, which looks like an inverted cylinder. What did they say here? Inverted measuring cylinder. And yeah, inverted cylinder would be correct. So measuring cylinder, inverted graduated cylinder, inverted measuring cylinder. So this is something you can memorize. This is like, it's part A is happen. Obviously A would be a funnel dropping the reactant in, not a burette. B is a delivery tube because it's delivering it. C is an inverted, it's inverted, right? It's upside down, inverted measuring cylinder. A student used this apparatus to collect sulfur dioxide gas. Explain why the student made a mistake using this apparatus to collect sulfur dioxide gas. Obviously, I think it's wrong because, so sulfur dioxide, SO2, is heavier than air. Again, if you don't want to memorize them, SO2 is 32, okay, and it's more than 29, so it's heavier. Okay, and we know for heavier than air, they should use downward delivery. People can say, Walid, it's going down. How isn't this downward delivery? So, okay, in downward delivery, if you look at the picture, it's looking like the cylinder, the measuring cylinder, whatever you want to collect in, it's upward. It's not inverted. Why isn't it inverted? Okay, if it's inverted, how? Okay, the gas goes up here, so it's just gonna fall back down. It's gonna go out. If it weren't inverted like this, and the cylinder was like this, it's gonna sink and go down here into the cylinder. But since it's inverted, it's gonna escape. It's gonna go out. Okay, it's gonna go out here and it's gonna go out. خلاص. You know what I mean? So it's gonna escape the jar. So that's why you can say he should have used downward delivery, but they said explain. Again, explain why. Why should he have used explain? No, explain why. It's 2 marks. He should have used downward delivery. Why? Because SO2 or sulfur dioxide is heavier than air. So since it's heavier than air, it will escape from the jar. Okay, you memorize this example. Name one gas that can be collected using this apparatus. Since it's inverted and it looks like downward delivery won't work, that means he's going to use upward delivery would work, right? Upward delivery, what are stuff that's lighter than air? You could say ammonia, hydrogen. Hydrogen is the first one I can think of. Hydrogen is very light, right? So if they want to use this one, obviously it's going to be upward delivery because it's going up, right? For it to be upward delivery, it doesn't necessarily have to be above the reaction. It can go out, down, and then just go up. What matters is here. This is where the magic happens. It either goes up or it either sinks down. Okay? If they want to use this one, it's gonna go up. And to use something that goes up, it needs to be less dense air, so you use ammonia or hydrogen. Suggest a modification to collect sulfur dioxide gas. You may include a diagram. Of course, to collect sulfur dioxide, we said it should be downward delivery. So you just flip the measuring cylinder upside down, right? Flip the gas jar, whatever. They're calling this the gas jar for some reason. But now we said it's measuring cylinder. Yeah, you could say, yeah, don't say gas jar. Measuring cylinder. And I like saying measuring cylinder. And if they said draw a diagram, here they said you may include. May include, yani عادي, you don't care. If you don't want, don't draw. If you want, you can like put on the side هيك, small, and like tubes, whatever. It goes down, and the cake. See? And we can use an example from here, like this. See? Over here. Goes into it. طيب. Question 17. A student investigated the rate of reaction between HCl and excess calcium carbonate. The student used a gas syringe to collect and measure the amount of gas released as shown in the diagram. As the calcium carbonate was dropped into the hydrochloric acid solution, the volume of the carbon dioxide was monitored every 30 seconds at 25 degrees Celsius. Use the syringe diagram to record the volume. Okay, you have to. Okay. Of course, here you just label them. Let's just go down. Let me zoom out, try. So we can do them all at once. Of course, here it's going to be 0. Here it's going to be 30. Here it's going to be... I think it should be 2 significant figures, huh? Or 3. I don't know. I'll check the answers and see. So 0, 30. Here it's 40, between 45 and 50. So it's going to be 45, 46. Okay, 46. Here it's 55, 56, 57, 58. Here it's at 65, very easy. Here it's at 70, very easy. And here it's at 70. So let's compare our answers. It should be, see, 0, 30, 46, 58, 65, 70, 70. There's a third one. Come in, hold. 70, of course it's 70. Plot the result. Okay, you know what, let's plot them. So at time 0 it was 0, so obviously it's gonna go here. At time 30 it was at 30, so we're gonna go here 30, and over here 30. So hey, she hon right here. Go up now. At 60 it was at 46, so we're gonna go 60. هنطلع فوق لعند 46. So over 1, 2, 3, 4, 5, 6 over here. Okay, 90 it was at 58. So you go to 90, you go up 60. Okay, my eyes, I'm dizzy, man. 90, so 58.
Gigi,
Oh, nasty.
free to. 23 to.
Okay, hold on, I'm gonna cut to when I'm done now.
Okay, next gear.
Okay, so I'm done plotting all the points. One thing that's good to remember is please plot the points with X's. Okay, after you draw the point, put an X above each one. For external exams, if you don't do this, you're gonna lose the mark. And SABIS, with previous experience, if you don't do it, you will also lose the mark. For scientific subjects like physics, chemistry, and biology, you need to label it with X's. Then they said curve, so let's curve it. Okay. Okay, sorry about هيك تطلع هيك. Anyway, you get the idea. I'm on a computer. On a paper, it should be way easier. Use the graph and deduce the volume released after 80 seconds. So بتطلع لعند ال 80 هون. Let's find the graduation. 30 and there's 10 spaces in between, so that means each space is 3 seconds. And we want 80 seconds. So 60, 63, 66, 69, 72, 75, 78, 81. So 80 is over here. You want to go up to the graph with a ruler, of course. Up, 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 over here. So it should be around 55. Okay, so 55 centimeter cube. So clearly on the graph. So if you don't do this, you're gonna lose the mark. If instead of using gas syringe, another student he collected the gas using inverted 50 centimeter cube measuring cylinder filled with water. Okay, let's see. What's the gas we're collecting here? Carbon dioxide. Okay, carbon dioxide. We're collecting carbon dioxide gas. They're saying suggest an error. The first thing people will think, and no, it's not downward delivery. For CO2, it's actually 44. 12 plus 32, yeah, 44. And compared to air, 29, it's denser, so downward delivery inverted cylinder would be correct. So people will be like, huh, what's wrong with it? Use the keyword with water. Remember, with water, there are only two gases that work: oxygen, hydrogen, and nitrogen, because these are the soluble ones. So the error is it shouldn't be in water. So let's check the correct answer. Carbon dioxide. Yeah, carbon dioxide is soluble in water. These three are insoluble in water. For it to work with water, to collect the gas, you should use a gas that is insoluble in water, right? And those three that is possible, the only ones, the three gases that we took that are possible to use water delivery with, are oxygen, hydrogen, nitrogen, because they're gonna skip the water that's here. They're gonna skip it and go up into the tube that's being collected. Okay, so for that reason, carbon dioxide won't work since carbon dioxide is soluble in water. Easy, I'll just say carbon dioxide will dissolve in the water, right? So you won't be able to collect it. Remember here, we took it. The ones that work, oxygen, hydrogen, nitrogen. They will not dissolve in the water. They're going to go up into the tube. Suggest an improvement to fix the error other than using a gas syringe. You can just use downward delivery, right? You can use downward delivery. How do they say it? Using a downward delivery. So you can say replace it by using a 250 centimeter cube measuring cylinder. Just use a measuring cylinder instead of using water. Makes sense, yani. Okay, part E. Part E, the following expression is used to calculate the rate. Calculate the volume, collect between 30 seconds and 120 seconds. Okay, so the volume between 30 and 120. So at 30 we got, I think it was 30. And then at 120 we got, how much was it? 120. At 120 we had 65. So at 30 we had 30. At 120 we had 65. So between these two, what's the rate? The rate, they said, is the volume collected. So between 30 and 65, 35 was collected over the time. The time between 30 and 120 is 90 seconds. So do 35 divided by 90.
That's counting. It's so annoying.
And you get 0.38. So you could say 0.38. And obviously, it's incorrect without a unit. So you need to put the unit. Let's see, 0.38. What's the unit? Up you have centimeter cube, down you have seconds. So centimeter cube per second. Okay, always if you're calculating a rate, the denominator should be time. Second, hour, minute, whatever. Okay. 30, 0.38, 0.39. What are they rounded, يمكن? Yeah, okay, yeah, okay. It should be 0.39. Yeah, not 0.38. I don't know why I did this. And on my calculator, normal calculators don't do this. It's just the PC calculator. It puts it like this. Okay, on your calculator, you're gonna get this. If you round it, you get 0.39. Okay. F. On calculate the volume. I skipped part I. The volume, we calculated to be 35. Remember, we did 35 divided by 90. Yeah, that's the volume. And then they said calculate the rate. So here it's 0.39 centimeter cube per second. Okay, I just skipped this part. Very easy. Also, we did it to find the rate. Sketch on the same graph the expected curve if the concentration of HCl was increased. So now we're reacting two things: HCl and calcium carbonate, excess calcium carbonate. So when you increase, what did they say? Concentration? Increasing the concentration of hydrochloric. It's the limiting reagent. If you increase the concentration of the limiting, obviously there's going to be more product produced, because remember C is equal to N over V. If you're increasing the concentration, basically you're increasing the moles, you're increasing the amount. So there's going to be more moles produced at the end. So the curve will look like they didn't draw it for me. So نحن, if your original curve looked like this, هلا the new curve with more HCl is gonna look like this. Okay, if they told you sketch, as long as it's like this, it's correct. Okay, it just has to be above it, but the starting point should be the same. If the gas was hydrogen rather than carbon dioxide, would it be possible to collect it over water using a 250 centimeter cube measuring cylinder? Explain. Obviously yes. Why yes? Because we're using hydrogen, and hydrogen is insoluble in water, so it actually won't be absorbed by the water. It's going to go up and be collected. So هيك بنكون خلصنا chapter 1, topic 1. Good luck in your exam.